This demonstration is to demonstrate the features that were upgraded from a previous project. The two additions are a parallel parking feature and an intelligent distance adjustment for when the robot detects a wall, so that the robot can turn at close to as 90-degree angle as possible. There is a touch sensor on the front and back of the robot which will assist parallel parking. There is a light sensor on the front left corner of the robot to help locate the parking space for the robot to start parking in parallel. In addition, an upgrade to this project was that all firmware upgrades and code changes would be modified through Bluetooth. Let's see what happens. The robot detects a white object. The LED indicator shows that the robot is parallel parking. The touch sensor will locate the back of the parking space, which is represented by a book. The front of the parking space is also indicated by a book. The robot will sit in the parking space until something blue is detected by the light sensor. The robot is now locating the back of the parking space. The touch sensor indicates the back of the parking space. The robot is now leaving the parking space. Notice that the robot is approaching the wall at not a perpendicular angle. The robot will readjust to make sure that it can turn at 90 degrees. Notice the display to show the distances that it detects and the corrections that are required. Notice the 90-degree turn. The turning that's going on now is a result of the previous code changes to locate objects. Right now the robot thinks that it is in a closed-off location. Let's look what happens when the robot approaches the wall at a severe angle. It makes an initial adjustment and then makes small modifications afterwards. Notice that the LCD screen shows the status. It says fine adjustment, and it gives two different distances on the display that it's comparing. It's almost at perpendicular angle to the wall. Looks like it just overcorrected a little bit. Let's see if there you go. It just shifted back. Let's see what happens. Perfectly perpendicular turn. The Bricks Command Center was used as the IDE to program the robot for this project. This is the NXC code. This target task demonstrates the location of the code where the robot determines the mode of operation. Notice the switch statement for the white case and for the blue case. Those two cases, the white case was for the parallel parking, and the blue case was to get out of the parallel parking. The turn task was updated to determine the distance, as you can see, and then a second distance where a reference point was made on the wall, and modifications of the position of the robot were made so that the robot could maintain a perpendicular angle to the wall before making a 90-degree turn. Currently, the program is not connected to the robot. Using this IDE, we can connect to the brick through Bluetooth, which is abbreviated as BTH, by clicking OK. Notice that the indicators change color and that on the brick display, the upper left-hand corner is indicated as connected to Bluetooth by a diamond. This is to demonstrate that the robot was connected through Bluetooth wirelessly.